In geometry section 2.3, we're dealing with conditional statements. So again, we're going to continue with dealing with phrases before we get into math. Although there'll be some math questions there. So conditional statements, like last section, we knew that statements was either true or false. But when you have conditional statements, that means it's basically what is called an if and then statement. So if something happens, then something will happen. So basically, here's my two statements. Conditional statements are compound statements. You have two statements in one. So P and Q, all right? Statement P, you buy a car, and statement Q, you get $1,500 back. So when I want to put it into a conditional statement, it's P arrow Q. That arrow tells me it's if P, and the P is my hypothesis, it becomes my hypothesis, then Q. And Q is my conclusion. So if you buy a car, then you get $1,500 back. So again, this is my symbol for if P, then Q. That arrow tells me that it's a conditional statement. So my hypothesis is you buy a car. That's my hypothesis. And my conclusion is the one after the word then is you get $1,500. So go ahead and write that down. Make sure you have your vocabulary all set. And we're going to move on to our next one. Okay, this one is talking about 4 different related statements. Now we dealt with conditional already. It's the original statement P, then Q. If two angles are congruent, then they have the same measure. That's true, right? If two angles are congruent, then they have the same measure. So the converse is basically, I'm going to take, this is if, the word after the word, the phrase after the word if, that's my what? Hypothesis. Okay? This one, after the word then, this is my conclusion. The converse is basically we're going to switch the hypothesis and the conclusion. So in this one I originally have P then Q, and this one I have Q then P. So I'm going to take my hypothesis right here and then my conclusion, and I'm going to flip them. So this comes first and then this. So if two angles have the same measure, okay, have the same measure, the sentence still has to make sense. Then I put the hypothesis. They are congruent. Alright, so in the inverse, basically what we're going to do is we're going to take our original statement with this, which is conditional, and I'm going to negate it. So negate, remember, has that squiggly line. So I'm going to take P then Q, but I'm going to put not P then not Q. So I'm going to go back to the original. So if two angles are not congruent, that term not, I don't know why I chose such a long statement, then they do not have the same measure. So it's the same amount, the same one, except they both have not. And finally, the contrapositive is we're going to take the converse and do the same thing. We're going to negate both of them. So it's not Q, then not P. So if, okay, I'm going to have the same exact one, but I'm going to put not. So if two angles do not have the same measure, then they are congruent. No, sorry, then they are not. Right, that's kind of long, it's kind of lengthy, but you get the statement. So the first one is conditional as our original. then we switch Q and P, which gives us our converse, our hypothesis and conclusion. Our inverse is the same thing as our conditional, but we have not on both of them. And our contrapositive is the same thing as our converse, but we switch both of them to not as well. So our first example is to identify the hypothesis and conclusion of each statement in the if and then form. So basically this is saying distance is positive. So distance, okay, is my hypothesis, and is positive is my conclusion. So if we measure distance, see how we did that? If we measure distance, then, sorry, I didn't write distance, because the distance is to be measured. If we measure distance, then it is positive. The last one is a five-sided polygon is a pentagon. So if the polygon is five-sided, then it is a pentagon. So this is our hypothesis. Okay, let's say that we're going to do our hypothesis one line and our conclusion with two. So this is our hypothesis, this is our conclusion, this is our hypothesis, this is our conclusion. So if a five-sided polygon, sorry, my apologies. It's supposed to say if a polygon is five-sided. We have to make it make sense. If a polygon is five-sided, then it is a pentagon. So if a polygon is five-sided, that's our hypothesis, then it is a pentagon. And that's our first example. So in this case right here, you're going to do page 94, number 4. Go ahead and pause and write it down, and we're going to move on to our last example. Our last example is to write a conditional, converse, inverse, and contrapositive. So those are our 4 statements. Okay? The first one is P, then Q. That's our conditional. The next one is our converse, which is Q, then P. Okay? We flip it. Then our next one is not P, then not Q. It's the same thing as our first one, except it's going to put not. And then the last one is not Q, then not P. So in this case, if it is a square, then it is a rectangle. Okay? Our next one is to switch it. So if it is, and remember, they don't have to be true. If it is a rectangle, then it is a square. This is not true. If all squares are rectangles, but all rectangles are not squares. So just because you're writing the statement doesn't mean that it's true. And this one, if it, and remember this is not, we're going to do the same thing as the first sentence, but we're going to put not. If it is not a square, then it is not a rectangle. The last one is not Q, then not P. So if it is not, we're going to do this same one, except we're going to put not in this one. If it is not a rectangle, then it is not a square. Right? So this one is go ahead and write this down. But the last one is page 95, number 10. Go ahead and try that. I know it's a lot of writing, but it's tedious, but it should make sense and the logic should be there. So try page 95, number 10 on your own, and I'll see you tomorrow in class.